So we're here in Bengaluru, India with a group of both international and Indian experts tackling the challenge of air pollution in India and how lower cost technology options that are coming about over the last few years can help in decision making to reduce pollution in the country.
Democratizing the models, air quality models, is a very good platform and it's a very good opportunity bringing all the stakeholders at one place and the streamlining all the air quality activities which are happening in India. What we need, the major takeaway is optimizing the data, optimizing the models, optimizing the usability of these models, and that's what will be the success of this program.
So reduced complexity air quality models seem to present, I guess, the best way forward to aid decision making in a time frame that makes sense to policymakers and different stakeholders. At the Pavitra project, we are seeking to build a high-fidelity, computationally efficient tool that leverages the capability of the smog emissions inventory, which is the best know-how that we have in terms of emissions for India, along with the INMAP reduced complexity model, to develop air quality predictions that let us know A, how well they're doing, and B, to figure out what scenarios work best in terms of air pollution mitigation.
I think we are on a right track. We know what are the problems. The problems are created by us, and we also know that how to tackle those problems. So it is collective efforts that we should put forward and try to make the cities cleaner.
Air pollution is a regional issue. We have different air quality models for air quality management. From these workshops, we get how CTMs and RCMs can be used for different decision makings and science, so that we can use it for science policy dialogue across political boundaries.
There is increased acceptance of chemical transport models for understanding emissions and pollution analysis in India and other countries. So the reduced complexity models can be really useful in bridging the gap between science and policy.
So my colleagues and I have developed a global INMAP, which is a global reduced complexity air quality model that can estimate changes in pollutant concentrations at up to 4 kilometers spatial resolution at the urban scale. And it can be run on a desktop computer, and simulations can be completed within hours rather than weeks or months. So we hope that this can sort of bridge the gap between air quality modeling and policy needs worldwide.
With the GAINS model, we are assisting the Government of India in taking airshed approach to air quality modeling in India. Our modeling exercise highlights the priority states and sectors for maximum reduction and effective cooperation.
My research group at Carnegie Mellon University is developing a model called EASIER. The idea behind this model is to take a very complex air pollution model and to boil it down into the simplest possible form so that decision makers can quickly assess how many lives will be saved from air pollution interventions. And this workshop is a great opportunity to talk about how to bring these tools from the academic sphere into public decision making.